Yeah, you're right. Okay, at any rate, that's why you divide this total by 16, because you got 16 squares in a dihybrid cross. Okay? You know, I told you when you cross this, you got 4 squares. When you make a dihybrid cross, you're going to have 16 squares. Does that make sense? Remember I told you when you cross this, it's always going to be 1 to 2 to 1. Whenever you do this, it's 1 to 2 to 2 to 4, 1 to 2, 1 to 2 to 1.
Whenever you cross this.
If I cross big A, big A, big B, big, with that, 1, going to have 4 1s, 4 2s, and 1 4. And I showed you how to get them right there. So in a dihybrid cross, when I do an F2, I get this, that, and I get that genotype. The genotype is the same. Monohybrid cross is 1 to 2 to 1, and a dihybrid cross is 1 to 2 to 2 to 4, 1 to 2, 1 to 2 to 1. It's always that. It's never going to change. So I can interpret that different ways. Just like I interpret the monohybrid cross as 3 to 1 or 1 to 2 to 1, I can interpret this different ways. Let me just throw one out. Let me rewrite. I just rewrote that here. This right here, I just rewrote it here.
Okay.
What ratio is this? Right, you see that? What do the 9 have in common?
It looks like it's A and B. I mean, homonym. Dominant A and B.
They all have a big A and a big B. Okay. These 9 all have a big A and a big B. What does this have in common? Little A's and at least 1 big B. Little B's and at least 1 big A. And the 1 is obvious. All little. So help me with this. 1 times 70, 2 times 70, 3 times 70, 4 times 70, 5 times 70, 6 times 70, 7 times 70. I'm just going through it this way because I want you to see it. You wouldn't do this in real life because I would just say, what number times 70 will give me these 2 numbers? Because I divide and I know what each square has in it. So each one of those squares will have 70. Just like 9 squares had a big A and a big B, 3 have a little A's and big B's, so on. So that's where I get that from this, but I know what that is over there. Okay. What is 7 times 70?
14. Sorry. 140.
Somebody else.
149.
7 times, let me give you a hint. 7 times 7 is 49.
Right.
What is it? See, you're saying 490. I'm saying, I can't hear you. But you say 490. That's my 7. What number times 70 will give me this?
9.
9. That's how I know it's a 9 to 7 ratio. There are other ways of doing this, but this is just one way. If you go to page 95 in your textbook, it will give you all the dihybrid ratios. Well, it'll give you 75% of them that we know of. Yeah, page 95. Page 95. See that table at the bottom of page 95? That's all the dihybrid ratios. So what are some of the dihybrid ratios? Obviously, it's not as easy as a monohybrid ratio. 9 to 7, 9 to 3 to 3 to 1, 9 to 6 to 1, 15 to 1, 13 to 3, 12 to 3 to 1.
So when you
All
have,
of those are dihybrid ratios.
when you have two numbers like that, do you have to consider those six
6, what do you mean?
those 6 ratios you just gave for the other
On
numbers?
page 95 is a better
No, I'm
representation.
saying like so when you see like for
It's
instance
a dihybrid.
right.
You know it's one of these.
Yes, I'm saying when you how to say this, like so when you go through and you see the numbers like it's only 2, it's 360 and 490. You gotta think about it. It's not 9 3 3 to 1. You cross that out and you know it's only gonna be those 4, both those 2, 3.
Yeah.
Okay.
Right? So you do this, divide the total, and get how many, and you can figure out what ratio it is. So what I'm going to ask you now, where's my 9 for my 9 to 7?
Where's your 9?
Yeah,
It's in the top half that.
that's my 9, and the rest of them are 7. Well, that was easy enough. So we converted that 3 to 3 to 1 to be 7. Why do the 3 to 1 show white? Because that's what we got, 490 is white. Why does this show white? And why does this show purple?
Because the dark well Jordan
The way he explained it this morning
well,
was
most of the A's because they're more down like
because
the big A no.
We didn't,
yeah, we did. It starts with an R, doesn't it?
Okay, that's good. All I'm trying to do is get you to think about it. This whole process,
this is just an example. We got to see.
all of these are dihybrid ratios. I can say, if I leave out the 9, 3, 3 to 1, because it can work either way. These ratios show gene interaction. Okay? Some people use the word epistasis. I prefer gene interaction.
Epistasis.
That means that the genes work together. So I don't like to use the word dominant here, because these genes are working together to get you the color. You know, in dominance, one gene shows itself, another gene cannot. But here, one gene works with another gene. So can you tell me how I got purple here? Thinking that, yes. Okay, and give you purple. That's right. And that's how you get 9 to 7.
You have 2 different allele that's working on the same trait. Is that
A and B works together to give you
the
purple.
same?
And in that drawing I gave, that handout, I literally walk you through it. Now, here's the key question. What is the genotype of the parent?
The genotype of the parent of F2 or F1?
Oh, which one?
White and white.
Oh, those you said they're always going to be.
But that's not the genotype.
Oh.
I want the genotype of the parent.
Big
Oh,
W,
big R,
big
little
W, little big W, big W, little W. Or wait a minute.
Look, we just did A's and B's like this. So let's use A's and B's.
So big,
What is the genotype of the parent?